Two massive fault lines, one deadly domino effect. Imagine waking up to the news that a colossal quake is about to hit the Pacific Northwest. A magnitude 9 event on the Cascadia Subduction Zone is the known threat. But new research from Oregon State University suggests the danger could extend south, with the San Andreas Fault activating soon after. As marine geologist Chris Goldfinger warns, this may not be just Cascadia's big one, but the start of a chain reaction. In this video, we unpack the evidence behind that link and what it could mean for the entire US West Coast. The west coast of North America lies along the Pacific Ring of Fire, a zone where tectonic plates collide with incredible force. One of the major players here is the Cascadia Subduction Zone, stretching nearly 1,600 kilometers from Vancouver to Northern California. In this zone, the Juan de Fuca Plate dives beneath the North American plate and is capable of producing magnitude 9 earthquakes or stronger. By comparison, the San Andreas Fault, which runs more than 1,200 kilometers from California to Baja California, generates powerful side-to-side strike-slip earthquakes. The most famous, like the 1,906 San Francisco quake, have reached magnitude 7.9. For a long time, scientists believed these two fault systems acted independently, but that view is changing. Researchers like Chris Goldfinger have shown that stress from one fault can travel hundreds of kilometers and trigger another. It's called the seismic domino effect, when one rupture sends pressure into the next fault zone. Think of these as two very different earthquake personalities. Cascadia is a subduction megathrust. One plate drives beneath another and lifts the seafloor, which is why it can produce M8.7 to M9 quakes. This geometry can lift the seafloor and displace water, so local tsunamis could arrive in about 10 to 30 minutes on parts of the Oregon, Washington, British Columbia, and Northern California coast. San Andreas is a strike-slip transform fault. The plates slide sideways. That sideways motion delivers intense urban shaking and surface rupture that can cut roads, pipelines, and power lines, typically in the EM7 to EM8 range. It rarely generates large tsunamis, but it can trigger fires and cascading infrastructure failures across Los Angeles, the Inland Empire, and the Bay Area. Cascadia lifts, tsunami threat, San Andreas slides, urban damage. Either one is bad. Together, they create a compound disaster where long-duration shaking and coastal flooding in the north could be followed by brutal, infrastructure-crushing shaking to the south. And it's not just theory anymore. Recent studies of deep-sea sediments show that Cascadia and San Andreas have produced earthquakes at nearly the same time, repeatedly, over the past 3,000 years. It's like tuning two analog radios to the same frequency. When one moves, the other often responds. This discovery isn't guesswork. It's built on decades of ocean drilling and paleoseismic research. The key evidence comes from something called turbidites, layers of sediment created by underwater landslides, which are often triggered by big earthquakes. When a quake hits, it shakes loose material on the ocean floor, causing it to tumble down and settle into layers, like pages in a history book written in mud and sand. Chris Goldfinger's team at Oregon State University drilled deep into the seafloor near the Mendocino Triple Junction, where three tectonic plates collided. There, they pulled up over 130 core samples, each one preserving thousands of years of seismic history. What they found was striking. Many of the cores contained doublets, two distinct layers stacked on top of each other. A fine, silty layer underneath, a thicker, sandy one above. The pattern wasn't random. It pointed to two separate earthquakes happening close together in time. That core showed the same signature, a fine layer deposited by a Cascadia quake, followed shortly by a sandy layer likely caused by a San Andreas rupture. Using radiocarbon dating and analyzing the layer sequences, scientists confirmed that these earthquakes occurred back-to-back. In some youngest cores, the absence of an intervening layer suggests minutes to hours separation. In other pairs, it's months to years. Across dozens of cores, paired turbidites often line up in time, implying closely spaced ruptures. In many cases, Cascadia appears to precede San Andreas. The consistency of these twin quakes across thousands of years makes one thing clear. This isn't coincidence. It's a geological pattern, a kind of domino effect written into the Earth's memory. Let's go back in time to the strongest clue yet. One of the most revealing cases happened on the 26th of January, 1700. That night, a powerful Cascadia Megathrust earthquake struck the Pacific Northwest, unleashing a tsunami that traveled across the ocean and hit Japan. Remarkably, the exact date and time, 9 p.m., are known thanks to detailed Japanese records documenting the arrival of the waves. But here's where it gets more unsettling. There are signs that the San Andreas Fault may have ruptured shortly after. Coastal sediment studies and tree damage in California point to a large quake happening between 1,698 and 1,700. As Chris Goldfinger puts it, we know the Cascadia quake occurred at 9 p.m. on the 26th of January 1700, and now we think San Andreas followed shortly after, maybe within hours. There are no colonial records from California at the time to confirm it, but indigenous oral histories and sediment evidence strongly support the idea. The takeaway is chilling. A magnitude 9 Cascadia Megathrust quake might not come alone. It could trigger a major rupture on the San Andreas Fault within hours or days. This isn't just a distant possibility, it's a scenario grounded in real data. As Goldfinger emphasizes, in the 3 clearest earthquake pairs from the past 1,500 years, including 1,700, both faults appear to have ruptured within the same year, likely within hours or even as little as 30 minutes apart. This kind of seismic chain reaction poses a massive threat to the US West Coast. If both Cascadia and the San Andreas Fault rupture around the same time, it could trigger a dual catastrophe unlike anything ever seen. Chris Goldfinger warns that a major earthquake on either fault would already draw all of the country's resources to that region. But if both go, cities like San Francisco, Portland, Seattle, and Vancouver could all be in simultaneous crisis. To put it in perspective, the United States Geological Survey shakeout scenario for a M7.8 Southern San Andreas event estimates about 1,800 deaths, 500,000 injuries, and roughly $200 billion in losses. Now imagine stacking a Cascadia Megathrust quake on top of that. Hospitals overwhelmed, emergency shelters full, and supply chains severely strained. Geological records show this is not a rare fluke. Cascadia's megathrust earthquakes tend to happen every 400 to 600 years. San Andreas quakes recur more frequently every 200 to 300 years. It's now been over 300 years since Cascadia's last major rupture in 1700, and decades since San Francisco's damaging 1989 quake. Many scientists feel the clock is ticking. The US West Coast is home to tens of millions of people, vital infrastructure, major tech hubs, and critical ports. A simultaneous rupture of Cascadia and San Andreas would cripple transportation, disrupt water and power systems, and paralyze emergency services from British Columbia to Baja California. And unlike hurricanes or volcanoes, earthquakes give no warning. When it happens, it's instant. That's why researchers and public agencies emphasize early warning systems, emergency drills, and building retrofits. New AI-powered monitoring tools are improving our ability to spot unusual patterns, like slow slip events or microseismic swarms. But we're still a long way from being able to predict the exact time of a rupture. So how do we prepare for the unthinkable? Preparation is key. Urban centers need to invest in earthquake-resilient construction, especially for hospitals, bridges, and high-rises. Coastal communities should rehearse tsunami evacuation routes regularly. Goldfinger and other researchers aren't ringing alarm bells for drama. They're translating hard data into urgent insight. The past leaves messages in layers of mud and broken rock. And if we listen carefully, it's telling us that the next really big one might not come alone. A growing body of geological, historical, and deep-sea evidence paints a sobering picture. The next major disaster on the US. West Coast may not come from a single quake, but from a chain reaction of earthquakes. This seismic dance is silent but immense, and our cities sit directly on its stage. Each layer of marine sediment and each scar in ancient tree rings whispers the same warning. The past never forgets, and it may return with a vengeance. Ignoring these signals is a risk no community can afford to take. The good news? With awareness and action, we can strengthen our defenses. Taking paleoseismic research seriously means reinforcing buildings, developing multi-stage evacuation plans, educating the public, and expanding scientific monitoring. As Goldfinger puts it, when these faults rupture in near unison, the result could be a humanitarian catastrophe. That's why prevention grounded in science is our strongest shield. every measure we take today may save lives tomorrow. If you found this analysis helpful and want to stay informed about the latest research and alerts on geological threats from the West Coast to around the world, don't forget to subscribe to the channel. Stay informed, share this knowledge, and prepare for a future where awareness and preparedness make all the difference. The Earth won't wait. Our best defense is information and the conscious action we take in response to it.